Again, we're going to hear from Kevin Truckenmiller. Am I pronouncing that right?
Yeah.
Excellent. From SPS Commerce is gonna talk about this whole deploying all the things thing. So give it up for Kevin.
Thank you. So, deploying all the things. I know it sounds kind of like too global for this kind of a conversation, but when you're a cloud automation engineer, you usually have to do that, just that, deploy all things. I have this thing, you need to deploy it, here, take this, do something with it. And then as a cloud automation engineer, we have to do that, but we also focus on building abstractions or abstraction layers for the developers so that they can more easily reason about how their application gets deployed. And that's kind of what I want to talk to you about today, is at SPS, how do we push stuff out to production, and where did our journey start? And how did we start deploying all the things? But first, I want to go into a little bit of philosophy. I started coming to these DevOps talks when, I don't know, a couple years ago. I was not a DevOps specialist. I just was just a humble musician, just coming here to learn how to, I don't know, how everybody did things. And I think it's so important to stay humble because that gives you the pain of not knowing something and asking and inquiring and coming here and just figuring out what this is all about. So that's something that I like to stress in my day-to-day life, that no matter how much I feel like I know, I still don't know enough. And even if I think I'm right, tomorrow I may not be. So that's why I come here, and the talk that we just heard was amazing, so hopefully you learned something from me. I like to make things simple as well. I know we as engineers try to make things complex because we're doing very complex things. But when we build things that are very, very complex, we often do a disservice till tomorrow because all that debt starts to build up and build up and build up. So if we don't tackle those problems on our side as developers and engineers, we leave tomorrow all clustered in a big garbage heap that somebody else has to untangle and figure out to get to the context of what you're trying to accomplish. So I really try and make things simple, and I try and do this on a day-to-day basis and make things pleasurable for our developers. And I know that's kind of a taboo word when I say pleasurable, but I truly think I want to make things sexy. Like I want to do the Steve Jobs to things. Like, hey, this isn't sexy enough. How can we make it simpler? How can we make it easier to use? And I think, drone is a great use case for that as well. Yeah, this is my boss. Deploy everything. So how I started about a little bit less than a year at this company, and I came in and they threw me in a pool and they said, all right, now swim. And then they started throwing water on me, and I was using Ansible for most of our deployments, and if you don't know what that is, it's just Bash and Python and just good old SSH, getting into servers and getting that config up and just getting it going, download the artifact, run the playbook, there you go. Here's like a stupid example of Ansible on Ansible's, I just ripped it from their website. But it's just as simple like, here, hosts, all the web servers, remote user, I'm gonna run as root, tasks, make sure Apache is at the latest version. Do this thing. Get the server up and running. It's an automated way for us to bring up a server. And that's what we started with, and that's what we still do today. I don't know if I'm ever going to get out of the land of Ansible, but you know what? I don't even care. I bought a book. I started reading it. After about 6 months, I finally feel like I have a great understanding of how Ansible works and how to use it. And like I said, this is how we deploy all the things, not just some of the things. Ansible is what we use a lot. But, so yeah, some of the successes was configuration as code. Ansible gives you that. Also, interoperability with AWS, it can do that as well. But the frustrations were, or at least from the developer side of things, was like, this is slow. It's taking me 40 minutes to provision this server. Like, isn't there anything that we can do? And some of the, the complexity of getting a developer to write a playbook is just, it's just kind of a non-starter. Sometimes they can get really in depth and, you don't really want to say, hey, go write a playbook for your deployment. We as a team, when I first joined, were pretty small. So we couldn't handle all the playbooks. So we wrote roles, but even handing a role over to developers, like, what's a role? I'm trying to build an app. I don't have time to it's your job. You deploy it. And so that was difficult, but we did a good job with it. And we used Jenkins, and we deployed a lot of the things. Then we started using Docker more and more. And I don't know about you guys, but I started developing using Docker. It was just kind of something that I liked. I think I went to AWS Awesome Days, and they said the word Docker, and I was like, oh, I'm gonna learn that this year. And then I just went home and I started using it. And before I would, on my AWS instances, I would, log in, whatever, do the thing. This is before I knew Ansible. And then I'd bring the server up and do all this garbage. And then I started using Docker, and I could just do Docker pull, like Node.js or something, point it to my code repository, or not code repository, but my code folder on my computer. And then I would have a web server just like that, just with like one command. And the minute that I did that with Docker, I was like, okay, I want more. Give me more. And we've been using it a lot at SPS because it gives you a lot of things. Immutability, your container itself shouldn't change. It shouldn't change. You build it in dev, test, stage, production. That container is the same thing. That's so cool to me. That's like your code base. It should react the same way throughout all the environments. And that's one of the things I learned to love about it. So we started using Mesosphere, kind of like Kubernetes. It's just a platform where we can deploy containers to. One of our really talented engineers, Jeremy Alexa, kind of started it up, got it running on all our environments, and built it to allow all of our developers to deploy to. And so we were charged with kind of building a system of getting our containers that the developers were building to each environment and using Mesos. And it gave us a multi-tenant feel, so you could have 2 containers on one host. You could have as many as you want, as many as is fiscally responsible. And it increased the velocity of our developers because they didn't have to wait for an Ansible playbook to run to bring up the host. It increased their velocity as well because once they deliver that artifact, they can deploy to dev, test the next minute, stage the next minute. I mean, it's just the deploy velocity just got amazing. So we started out with this concept, and they introduced it with Drone, but we started out with this concept as well as event-driven pipeline. When this thing happens, do this thing. It's not like polling, like, when are you going to call me? When are you going to call me? Next week? Please call me. Just call me. Oh, there's the build. Okay, now I'm going to do it. No, we have webhooks that from GitHub that kick off our pipeline that can deploy our containers to Mesosphere, which is kind of an awesome thing. So I was working on, with my team, kind of an abstraction layer for basic containers that people wanted to deliver. So the configuration that they had to write was as simple and as useful as possible. And we can customize this because we know our environment, we know what we need to deliver, so we can break it down to really, really small parts and keep that contract with the developer pretty simple. So this is we call a build deploy pipeline file, or a BDP file for short. This is kind of like a little bit like the drone syntax. It kind of looks the same, but you have a build step, and you have you want to go to Mesos, so there's Mesos, and then you describe your services on how you want them to run on that platform. And generation 1 looks kind of like this. I don't know if you guys use AWS or if you've used a lot of the services that AWS offers, but we really like using Lambda. We really like using SNS and DynamoDB, and yeah, our platform not only runs in AWS, but it also spans into the data center as well. And so this is kind of how generation 1 started, where we had this idea, let's make it all event-driven. Let's make our deploys all event-driven. So we got a GitHub commit, that hits an SNS, that kicks off the deployment and into Mesos. And we do, there's like a ton of intermediary things there, but that's the general gist of it. And now, what about deploying databases? Now, we rely heavily on AWS to provision our databases, and we use Ansible still to get our databases up and running. And I'm not on the DBE team, but they use a thing called Liquibase to orchestrate all that layer. And what about builds? Well, here at the company, the developers still have Jenkins servers for all their little individual builds. And this is not build all things, this is deploy all things. So I'm just going to point you to a little link that I have on my GitHub. It's an AWS container build pipeline that you can get going in AWS. It's just a Ansible playbook away. Now, what about serverless? Serverless is essentially just calling a function, saying, hey, I want this thing to run. And a lot of people are getting up API gateways in front of these Lambda functions in AWS. And AWS basically takes in that post request or that get request or whatever the web request is, and that serverless function will run the code that they've put into AWS. We're iterating on a bunch of different patterns for this, but one of the most interesting things I think about serverless functions is, well, what I think they are is they're containers. They're containers running in AWS somewhere, right? And a container is not a virtual machine, it's not a VM. You have to think of a container as a universal binary. Like, it can run on any computer that you put it on. You don't have to install anything. There's any prerequisites except for Docker or so forth. But AWS is just using containers on the back end with their S3 storage to run your functions. And I think when I first said this, my team was like, you're crazy. Like, what are you talking about? Like, and it was just a supposition of mine, to be honest. I didn't know this for sure. But then I went to AWS's website, and it says, AWS Lambda, how does it work? And essentially, it's just a container that's running your code. You upload your code to AWS and it runs. But the problem that we had with AWS was it had restrictions, and you only have 512 megabytes disk space. You have a maximum execution time. So a lot of our developers were like, hey, this is cool. We'd love to use AWS Lambda, but we need 8 gigabytes of memory. We need to run this process for, I don't know, however long we want to. And we need, I don't know, more than 100 concurrent executions. So we started to just think outside the box a little bit. And we thought about, okay, serverless is just running in containers. What if we just made an AWS Lambda-like service here that we can run containers and do it on demand and then scale down to 0 whenever they stop executing whatever it is they're executing. Enter this SPS task running cluster. So we can run with as much memory as we fiscally feel is responsible. We create our own execution time, which, let's just say, okay, everybody, after 8 hours, you got to clean up your shit and go home with whatever container you have running out there. So that's what we felt was responsible. And we can run in scale to whatever size we want to. We have generous storage restrictions, and we're just relying on Docker to do all that stuff. And a little bit, how does it work? And this kind of goes back to that BDP file that I was specifying before. This is just you declaring your container. Once you build your runtime and you have a contract with us, you're saying it's going to exit within 8 hours. Once you build that container and upload it, in your repository, you have this file, and you commit it, and that shell exists then. That shell is just basically like, it's primed and is ready. Now all you have to do is execute that container with parameters, and we will run it for you on our task running cluster. So just sprinkle in a little bit of Python to invoke the specific Lambda that in question. This is a router Lambda. This routes your container execution to a specific cluster that we want it to run on. And then you could just fire as many executions as you want at it, and we will put them on a queue and run them And this is a little bit how it works. We have your users or your Lambda functions or whatever it is. You could have a service that's just executing these Docker containers and starting these processes. But they just talk to this router. The router then puts it on the queue. And this other guy, this task runner, he's going to try and schedule that work for us. And he's just going to keep on doing that all day. He's going to make sure that it runs on this cluster. And we use a Dynamo table in here, which is not shown, but it helps us keep state and helps us log and helps us do a lot of other things like cleanup and whatnot. And then we have this scale down cron. This guy just watches the cluster and he says, well, if there's any instances out here that are being underutilized, I'm going to tell them to pack up their shit and go home. And we're going to scale this cluster down to 0. Like we can keep this moving in a lean, really lean environment, or we can scale it out to however much we want to scale it out to. So this is like one of the most exciting things I've worked on all year, and I just wanted to share it with you as to not only are we developing abstractions for serverless and deploying to serverless, but we're also thinking about maybe not all applications want to abide by AWS Lambda's contract. Maybe they want to get outside of that contract. And so here at SPS, we want to try and do that as well. So food for thought. We are going through much of the struggles that the guys before me talked about, which is how do we clean up our Jenkins situation. I think Drone is a great pattern to do that. And we are looking into using code build to do that, just spawning our build processes. So you could have 4 builds within your repository that you want to trigger to a specific deployment. And code build would just say, I can build 1 to n builds in parallel. And we're looking into using AWS in order to handle all of our builds. And we're going to do them all in containers for the most part. All of our applications can do so. We're using a lot of ECS as well as Mesos. And we're expanding this task running cluster to do a little bit more than just running tasks. Like, it could do deployments for us. It could do a lot of other things. And we're using Alpine Linux as a means to make our containers smaller. We're using ECS to deploy web applications. And when we're scaling in and out with our web applications, it makes a lot of sense to keep your containers very, very small. And Alpine Linux helps us to do that. But overall, we're just focused on that developer experience. Because really, if they don't have to focus on us or, we don't have to make a playbook for them, if we can just give them like a small little file, then we'll create something for them that they can invoke. That's kind of where we want to get as engineers, is develop something that allows these developers to increase their velocity. That's all I got. Thank you.
I'm far too impatient to hold the button long enough to turn these mics on. Kevin, that was really cool. And I imagine we may have a question or two. Let's just make sure that we give people a chance to ask questions for the recording before everybody just comes up and talks to you individually, which I imagine is also going to happen. Everybody is like, we want to just come and ask you individually. So I will actually ask you myself. When you decided, and I remember it was months ago now that we had Paul DeCourcy here talking about the experience you were having with Lambda. Can you shed any light for people who might be trying to make this sort of decision? Like, what's the tipping point that makes you decide you can't really accomplish what you're trying to accomplish with Lambda? You need your own task cluster. Like, hey, your own novel task running cluster that's not Lambda sounds like a lot of extra stuff to do. What's the tipping point that makes you decide, we need this?
I think there's a couple different reasons that come to mind, but really it's just cheaper. When you're running a ton of work, it's probably cheaper to get an EC2 instance and to run it on that because you can maximize the cost savings there. But if you're getting, and most of the stuff that we run is infrequent, not really highly utilized stuff. So AWS Lambda makes a lot of sense for that. Because at home, I run, like, I don't know how many different Lambda functions, but I don't really pay anything for them because they don't cost any money unless they're invoked like a bajillion times. But if you have a service that's just getting hammered with requests, that's going to be kind of expensive on Lambda. So I kind of use that metric. And then obviously the memory request thing, like if I need an application that requires more memory, I have to run it on EC2 or in another environment.
Great, thank you.
For building the task running cluster, have you open sourced it, or are you looking at it, or is there an existing open source solution that you can point people to as a starting point?
Yeah, so that's a specific one my company owns. We have this platform on Mesos called Aromatic, which is for Apache Mesos. I'm sure there's tons out there. So yeah, we used Aromatic a lot. I just felt like, it didn't have the scaling capabilities of this one. I really like that this one can scale into 0. And for me, it's like the company had one thought, which was move to the cloud. And then they had another thought, which was, oh shit, the cloud costs a lot of money. So I think the basic way we architect all of our application architecture, or we architect everything, was we want it to scale to 0 when it can. Because there's no use having an application doing nothing. It doesn't do the universe any good.
Great, excellent. And we'll do one more question.
Thanks for the presentation. Evented pipelines, very cool. So you mentioned your developers have their own Jenkins. Is that correct?
Groups.
Groups. So each groups of them have masters. Does that become a hassle to manage for the ops team?
Yes. I mean, personally, I have a Jenkins at home. I love Jenkins, but I think as a company, we have to make the distinction between maintainability and, like I said, not leaving a mess for tomorrow. And it's a philosophy that I hold the core to my being, which is making patterns that, like they said, just clean up after themselves. I don't like to use the term die. That's just kind of harsh, but I like to use the term clean up after yourself. Don't leave a mess. And then keep your config as code so I can resurrect it tomorrow if you're sick, or you know what I mean? Like, it's got to be somewhere. Let's just keep it in the code. And then we have a platform where we can run the build on. And that's where I would like to see us move. And that's where I'm moving. Yeah.
All right, fantastic. Thank you so much, Kevin. Give it up for Kevin again, everyone.